In this video, I'm going to use one big problem to review central limit theorem, CLT. So what is central limit theorem? We have a population. So this is my population. And then what is the distribution of this population? I don't care. Now, I am going to take samples. First sample, second sample, third sample, fourth sample, fifth sample, so on and so forth. And then for each sample, what is a sample? So consider population is a huge list of number. The size is very large. I take a sample of it, so I take a piece of it. So that means I grab some number from the pool. I grab some numbers from the pool. And then for each sample, since I have a few numbers on my hand, I want to calculate the sample mean. So you add them up, divided by the sample size, then you get your sample mean, right? So for each sample, you have a sample mean, right? We have many sample. Okay, now what I am interested is the distribution of this x bar. So what is the distribution of this x bar? The central limit theorem says if the sample size is large enough, so let's say n is greater than or equal to 30, then the sample mean, so that means this x bar, so central limit theorem says as long as the sample size is greater than or equal to 30, the distribution of this sample means forms their own normal distribution. So this x bars you see right there has their own normal distribution. All right, has their own normal distribution. As long as sample size is greater than or equal to 30, this x bar has their own normal distribution with mean mu and then standard deviation sigma divided by square root of n. You can also call this standard error, or you call this SE. All right, how do you standardize? So in this case, the x bar is a random variable that follows normal distribution with this mean mu and this standard error. And the way we standardize is z equals to x bar minus mu divided by sigma over square root of n. When do we use this formula? When the sample size is mentioned in a problem, you have to use this formula. So when you use this formula, we are not standardizing one number, we are standardizing the average. We are standardizing x bar. So what about back to the normal distribution? You have seen this before, right? X minus mu divided by sigma. This one is we consider one person only. We consider one x, one number only. So you can still divide it by square root of n, but if you take sigma divided by square root of n, which is one person only, that is just equals to sigma, right? So if you consider one person, there is no need to divide it by the square root of n. All right. Now, what happened in this problem? This problem, they are talking about a hybrid course. So what is a hybrid course? Hybrid course is maybe, so for example, when you learn from your lecture, you watch all the videos online. So you watch videos online, you do homework online, sometimes you take quizzes online. But hybrid course is sometimes they ask you to come to show up in person to take a test, because when you take a big exams like midterms or final, they cannot let you do it online because you might hire someone else to do it for you, right? So they want you to do it in person. So that is a hybrid course. And then they use a software to find out how many hours students spend online. So the average they found is mu equals to 100 hours. So on average, people spend 100 hours online, and then this is a sample size of 25 students. And then do you see the highlight in yellow? The population variance is sigma square equals to 400. So this one, I use sigma in my formula, right? So to find my sigma, you take the square root of that, you get 20. Do you always take square root? No, you have to read the problem. If they say the sample standard, if they say population standard deviation, then you have your sigma, then you don't take square root. If they give you a population variance, which is a sigma square, then you have to take your square root. So read the problem carefully. They won't highlight these things for you. They will just say population variance and then leave the rest of the work to you. So now we got everything we want. So what's the first problem asking? The first problem asking average number of hour no more than 94. So A is asking probability average no more than, what is the opposite of more than? Less than or equal to 94, right? So less than or equal to 94, this is the same as at most 94. So we standardize that. So this is a z less than or equal to 94 minus 100 divided by sigma over square root of n, and then we find out what this is. So z less than or equal to 98, 98, right? Not 98, 94. 94 minus 100 divided by 20 over the square root of 25. So don't make a mistake on your typing. Check your work. I use a parenthesis for the numerator, one parenthesis for the denominator, and don't forget to close your parenthesis. So that equals to negative 1.5. If you take a look at a picture, we have a standard normal curve, mean equals to 0, negative 1.5 less than or equal to is the left hand side. And then the calculator command is normal CDF, cumulative density function, meaning that you are looking for area under a normal curve. From negative infinity, which is the left cut, and then the right cut is 1.5, mean is equals to 0, standard deviation, standard error is equals to 1 because we are doing standard normal z. Z means mu equals to 0, standard deviation equals to 1, standard normal distribution. And then second was normal CDF. From negative infinity, you type negative 1, not minus 1, negative, the negative key between the decimal point and the decimal key, and the enter key. Second, comma, 99, and then negative 1.5, mean is 0, standard deviation is 1, then you get your probability. So the probability is 0.066. I usually use 4 decimal places for probability. So that is the answer to problem A. And then this procedure I just drew has all the works. So if you someone asks you to show all your work, then this is what you have to do. If you are doing a multiple choice problem where you don't need to show a single line of work, then there is a shortcut. So you do normal CDF. I take the 94 from negative infinity to 94, and then the mean before standardization is 100, and then the standard error is 20 divided by square root of 25. This is one step to get to the final answer. Sometimes the answers are not exactly the same. If you round the z, the answer might be a little bit different, but if you keep 4 decimal places, you will be okay. The difference is very, very tiny. So that will be the first one. The second one is no less than 102. If you want the problem, so I can go back to the top real quick, so you can take a screenshot to get the problem, so you don't need to keep going back and forth. All right, take a screenshot. All right, back to B is no less than. The opposite of less than is greater than or equal to 102, so that is the same thing as at least. And then you standardize that. Divided by sigma over square root of n, and then you have a standardized time 102 minus 100 divided by, be careful with the parenthesis, because if you mess up this, then the whole problem is messed up. 0.5, 0, and then 0.5, they want a greater than, then this is my area. So you have a normal CDF from 0.5 to positive infinity, mean is 0, standard deviation is 1, second was normal CDF from 0.5 to positive infinity. The mean is 0, standard deviation is equals to 1, 0.3085. So that's your answer. And then you do normal CDF from, the shortcut. So I will start at 102, and then to positive infinity, that is before standardization. So the mean is equals to 100. The standard deviation is this. So that gives you the answer directly, all right, without showing a single line of work. But again, look at your quiz, your test, your midterm, whatever you are taking. If the problem says show work to earn full credits, you have to show it. If you don't show it, you earn a 0. C is a between 93 and 104. (93) and 104. 93, right? 93 and 104 exclusive. Is the equal or not equal important? The answer is no, because the random variable x bar is a continuous random variable. So let's standardize that. We have 93 minus 100 divided by 20 over square root of 25 z, no equal, right? And then 104 minus 100 divided by 20 over square root of 25. So we have 93 minus 100 divided by 20 over the square root of 25, negative 1.75. So this is a z, and then 104 minus 100 divided by 20 over the square root of 25, 1. Okay, and then you have a graph. This is a 0, negative 1.75. This is a 1. You want the area between them. Then the calculator command is normal CDF. From negative 1.75 to 1, mean is 0, standard deviation is 1. 1, mean is 0, standard deviation is 1. And then the probability is 0.8013. So that's the probability that you are looking for. So without showing any work, how do we get that? We take the 93 and the 104. So we do normal CDF. So 93 to 104 before standardization, mean is equals to 100, standard error 20 over square root of 25. So that is one step to get to this answer. Another question is the exclusive, inclusive important? The answer is no, they are not important at all, because x bar is a continuous random variable. That's the answer. And then we have 2 more probability problems to go. The first one is at most 85 hours, at most. So D at most, that was C, right? Yep. And then D at most, so at most is x bar less than or equal to 95. And then you standardize that. So we have 95 minus 100 divided by 20 over the square root of 25, negative 1.25. And then we get to the calculator command, right? Before we draw that, let's get a picture first. 0, negative 1.25, and then less than or equal to, we have this, and then normal CDF. From negative infinity to negative 1.25, the mean is 0, standard deviation is 1. Second was normal CDF. From negative infinity, wrong key, negative 1e 99, and then negative 1.25, the mean is 0, standard deviation is 1, then the probability is 1056. So that is my probability. Lazy people don't want to show work. Here is how. Normal CDF from negative infinity to 95, the mean is 100. The standard deviation is 20 divided by square root of 25. Of course, this is for before standardization. If you type this command, that means you are asking the calculator to do the standardization for you and then do the normal CDF, this command, and then give you the answer. So if you do this command, you ask the calculator to do everything for you, so you don't need to write a single line of number. And then for part E is at least 107.5. So D and then E, at least. So that is X. At least that will be a greater than or equal to 107.5. And then this is a Z greater than or equal to 107.5 minus the mean divided by sigma over square root of n. 107.5 minus 100 divided by 20 over the square root of 25, 1.875. Okay. Zero, 1.875 greater than or equal to, so we have a normal CDF from negative infinity, no, that is wrong. From 1.875 to positive infinity, 0, 1. There you go. So we have second verse, normal CDF, 1.875 to positive infinity, 0, 1. So this is a 0.0304. 0.0304. Yep. And then the shortcut, normal CDF from negative infinity. No, actually I do write the same mistake again. 107.5 to positive infinity, mean is equals to 100, standard deviation 20 divided by square root of 25. Make sure you use a comma to separate them if you are using an older calculator. So that is one step to get to this answer. So that's all the question I show you at the beginning of the video. I actually want to do a couple more percentile problem to practice the inverse normal distribution. So let me move up and then I will paste the problem. So this is the problem that I also want to discuss. So the first one is 32.9 percentile. I did not mention the word upper. I did not mention the word middle. So without the word upper or middle, 32.9 itself is 32.9% on the left hand side. So part F, you draw a graph, 0, and then you cut 32.9% on the left, and then the Z is inverse norm 0.329, 0 and 1. And then second verse, inverse norm 0.329, 0, 1. Negative 0.42, not 42, 442. 443 actually, round at 1 to the 2. And then this is a standardized value. You have to undo the standardization. That means you have to write the standardization formula out and then you solve for x bar. So we have x bar minus the mean divided by sigma over square root of n equals to the standardized value, which is the time, right? So I know time cannot be negative. I'm not saying the time is negative. The standardized time is negative. That means the time is below average. And then how do you solve that? So x bar, okay, let me make this easy for you. So let's say x minus 2 divided by 5 equals to 10. How do you solve it? X is equals to 10, you multiply 5, you add 2 to it, right? So, but this time the denominator is a fraction. So 443 times 20 over root 25, and then you add 100 to it. So negative 0.443 times 20 divided by the square root of 25, and then add 100 to it. So we have 98.228. The unit is in hour, right? You can round a little bit if you want to. To me, I say 98.2 is good enough because you don't need that many decimal places, right, for time. And then the top 5%, so part G, I mentioned the upper 5%. So G is the top, upper means top 5%. And then draw a standard normal curve, mean in the middle, and then 5%. So this is your Z, and then Z is inverse norm, 0.05, mean is 0, standard deviation is 1. So you have second vars, inverse norm 0.05, the mean is 0, standard deviation is 1, and then you have negative 1.645, and then this is on the left side, right? I am looking for the 5% on the right, so the one that I want is a positive 1.645, and then you undo the standardization process, which is x bar minus mu divided by sigma over square root of n equals to the standardized value. So you take 1.645, look at my calculator, you multiply 20 divided by square root of 25, no parenthesis is needed because we are following the order of operation. So the time is 10:106.58. So the highest 5% of usage, top highest 5%, the people who stay the longest online for this hybrid course is 106.58 hours. If you want to round this to one decimal place, 106.6 hours then, right? And then the last one is the middle 54.6%. So that is part H. You have 54.6% right in the middle. So I cut a piece in the middle, so that is 54.6%. And then how much do I have in here and here? So to find out, you have to take the entire piece, take 100 minus 54.6, and then divide it by 2. Let's do this in our calculator. Minus 54.6 divided by 2, and then you have 22.7. So that is 22.7%. That is 22.7%. And then the Z1, Z2, right? So that is the corresponding cut. And then Z1, what's the Z1? Z1 is you have inverse norm 0.227 and then 0.1, and then Z2 is just a positive. Second vars, inverse norm 0.227, 0.1. This is a negative 0.749, positive 0.749, and then you undo the standardization, one for the negative z, one for the positive z. So you have x bar minus the mean divided by sigma over square root of n 25. That is negative 0.749, and then do one for the positive, not plus, is a minus, because that's how the formula works. And then 25 divided by square root 20. Did I do this wrong? Oh, 20. So this is a 20 divided by root 25 equals to 0.749, and then negative, do the negative first. times 20 divided by the square root of 25. Looks good. And then do a shortcut. Second enter. Do you see the word entry? Second enter, that means I want to get the previous entry, and then you move your cursor, hit the left arrow all the way to the left, so you are highlighting the negative sign, right? Click DEL, delete, enter. There you go. Let's keep one decimal place, and then 103, right? 0.0. So you are taking this course and you spend around 93 to 103 hours online. You are the middle 54.6% of the user. They spend around 97 to 103 hours online. All right, so that will be all in this problem. If you think the video is helpful, don't forget to click the like for me and then click a subscribe. I promise it is worthwhile coming back to my channel to learn mathematics. All right, I see you all in the next video.